This is lesson 11 of the Quantum Mechanics, a mini lecture series, Einstein's work part 2. So in the previous video, I talked about the photoelectric effect, according to Einstein. So you've got a metal surface and you've got light coming in. Now in Einstein's picture, if you remember, light consists of these bundles, energy bundles. They're called energy quanta. Okay, quantum is singular, quanta is plural. And electrons get ejected with some kinetic energy, minus some work they need to do, some action they need to do to overcome, or I should say to escape the metal surface. So kinetic energy of the electrons is just the energy of the photon coming in. Okay, remember, because it's a one-to-one correspondence. Photon has energy HF minus W. This, from basic maths, if you recall, is a straight line. Okay, H is the gradient, the slope of a line. If you sketch it, look like this. Okay, this has got the form y equals mx plus b, but in this case it's minus b. Okay, where the y-axis is the kinetic energy, so kinetic energy of the photoelectrons. The x-axis is the frequency of light. Okay, frequency. And so you get a straight line like that. Okay, linear relation. So for every metal, if you plot a graph of this relation here, you will get straight lines. Now, this was only theoretical at the time when Einstein published his paper, and experimental evidence was needed to verify this. Now, as is the case in physics, you need, and science for that matter, you need experimental evidence to back up your theory. Okay, so why was it the case that this relation worked? Well, what was the underlying, was this actually working experimentally? Answer came from this guy. Between 1912 and 1917 at the University of Chicago in the States, physicist named Robert Millikan. Okay, he put Einstein's linear equation to the test, and what he found was quite shocking to his surprise, because he was a very hardcore classical physicist. He always got results which were straight lines, like this, when he plotted his results. Okay, even, and despite being very accurate, okay, he was literally scraping metal surfaces to prevent corrosion and oxidized layers. And he even put his experimental setup in a vacuum to prevent any atmospheric effects. So he basically spent 10 years of his life trying to disprove Einstein, but ended up winning a Nobel Prize in physics in 1923. Okay, that's how science works. It's all progress. You try to disprove someone else, but then if you can verify their theory, you become just equally as famous. So Einstein was right. If you plot a graph of the kinetic energy and the frequency of photoelectrons for any metal, let's say sodium, copper, etc., you will always get straight lines. And that was Einstein's great achievement of 1905.